Suppose you have 4 boxes, and the boxes I'm talking about are these blue things. We have 4 of them, right? Now, inside each box is a basket of apples, or in this case, an apple, and a basket of bananas. There's 1 apple in each basket, as you can see, and 3 bananas. Now, suppose we want to count how many total pieces of fruit we have. There's 2 ways to do this problem. The first way is to go ahead and add how many pieces of fruit are in each box. So there's 1 apple and 3 bananas, that's 4 pieces of fruit. And since we have 4 boxes and 4 pieces of fruit in each box, that would make 16 total pieces of fruit. The other way to do the problem is kind of what we're getting at with this lesson. Suppose we want to know how many apples are in our total. We would first multiply 4 times 1, because there's 1 apple in each basket and 4 boxes. That'd be 4 apples. Then we would count how many bananas are in each box, that's 3, and multiply by how many boxes there are, and that's 4, so that's 12 bananas. Going back to the visual here, just so you can kind of get an idea of what we're doing. So we see we have 3 bananas in each basket and 4 boxes, so that's 12 bananas, and 1, 2, 3, 4 total apples. If we do it that way, and then add how many apples we have and how many bananas we have 16 total pieces of fruit. In other words, we did the problem 2 different ways and arrived at the same answer. Now let's look at this problem. In this case, we have 2 apples instead of 1 in each basket. Everything else is the same. Again, if we do the way on the left and just figure out how many pieces of fruit are in each basket, that's 2 plus 3. So that's 5 total pieces of fruit in each box, and 5 times 4 boxes would be 20 pieces of fruit. If we do it the second way on the right, how many apples do we have total? Well, we have 2 apples in each box times 4, which is 8. So we actually have 8 total apples, and still nothing changed about the bananas. There's still 12 total bananas. 8 plus 12 is 20. Again, we arrive at the same answer. And we can do this again and again and again. This time you notice there's actually 5 apples in a basket. And real quick, that means there would be, let's get it pop up real quick so you can see. That means there would be 8 total pieces of fruit in a box, and 4 boxes makes 32 total pieces of fruit. Again, we would actually have 5 apples in each box times 4 boxes, 20 apples. 4 times 3, we'd have 12 total bananas. 20 plus 12, again, is 32. Get the same answer doing the problem 2 different ways. Now this is where it gets important. This is why we're doing the second method. Suppose this you have these 4 boxes, and again, but this time each basket is just labeled A, and you're not allowed to look to see how many apples are in there. In other words, you don't know how many are in there. So we're just going to label it A, and there's an unknown number of apples in there. It could be any number, right? Now let's just go ahead and keep the fact that there's 3 bananas in each basket. So what happens? Well, guess what? If we try to do the method on the left, we can't add the number of apples with the number of bananas because we don't know how many apples are in the basket. But if we do the method on the right, we can kind of generalize and say that there are 4 boxes times the number of apples in each basket. The way we would write that is 4A in math. And suppose, now that might be hard for some of you to imagine, but if you deal with the abstract concept in math, for example, you don't know how many apples are in the basket, you can kind of imagine a specific number that might help you. Let's suppose now there's 12 apples in the basket, right? Well, that would just be 4 times 12, which would be 48. But in general, 4 times whatever, right? 4 times however many apples are in the basket. And so if you're struggling with that, just kind of look at the picture here and just imagine there could be any number of apples in that basket. And the more specific examples you think of, the easier it is for you to understand that abstract concept. Now we're going to keep the same number of bananas, which is 12. And so in general, what I'm showing you is that this method on the right is the only way to simplify this problem. You can't simplify it using the method on the left. Now let's take it even more abstract. Suppose we don't know how many bananas are in each basket, and we still don't know how many apples are in each basket. Again, the method on the left won't work, so we'll just go ahead and use that method we were talking about on the right. We'd have 4 times however many apples are in the basket, so it'd be 4 times A. And then we'd have 4 times however many bananas are in each basket. And in general, we'd write that as 4A, which means 4 times the number of apples in each basket, plus 4B, 4 times the number of bananas in each basket. And that would give us the total number of pieces of fruit. Now we could go ahead and increase it to 6 boxes, and the same concept would hold. We'd have 6 boxes times the number of apples in each basket, and 6 boxes times the number of bananas in each basket. And in general, that would give us 6A plus 6B. Again, just suppose there's, 24 apples in each basket. That'd be 6 times 24. Let's suppose there's 30 bananas in each basket. That'd be 6 times 30. And you would have a specific number. But again, in math, we want to take it to the abstract. We don't know how many pieces of fruit we actually have. Now let's make it even more abstract. Suppose we don't know how many boxes there are. Suppose there's too many to count. Or suppose it changes from week to week. Then let's just suppose we would say N represents our number of boxes, so these blue things. And then A, of course, is apples and bananas. In this case, and now we're actually getting to the heart of this lesson, we would multiply the number of boxes times the number of apples in each basket and do the same thing for the bananas. And we would arrive at a general formula for giving us the number of pieces of fruit that we have. The name of this concept is called the distributive. So we're distributing multiplication, property of multiplication. And let's go ahead and look at some examples. Specific examples. Let's read this together. 5 times 7 plus 3 is equal to 5 times what number? So we're trying to find what goes in this box, plus 5 times 3. Now notice this problem isn't asking you to find a specific, you know 7 plus 3 is 10 and 5 times 10 is 50, yes, but it's actually questioning or quizzing you on whether or not you can distribute the multiplication like we did in the previous examples. So what we're going to go ahead and do for our first step is we're going to just draw some arrows. So what we're going to do is be multiplying 5 times the first number, which is 7, and then we're going to take 5 and multiply the second number, which is 3. So for the first step, what I want you to do is just draw your arrows. And when you get good at it, you don't always have to do that, but it really helps you conceptually see how this works. So we can kind of see that drops down 5 times 7 for the second step. And then we had the 5 times 3. And so what we're doing for the second step is we're writing out that multiplication. That's all we're doing. Notice the right-hand side of the equation stays exactly the same. And for this particular example, we don't have to simplify. Why? Because we can go ahead and see that the left and right side of the equation is exactly the same. So this must be 7, what goes in the box. So again, this question is just quizzing you on whether or not you can distribute 5 to the 7 and the 3, and therefore 7 goes in the box. Next example, we have 9 times 5 plus 2 is equal to 45 plus what? So in this case, we're actually going to simplify a little bit to figure out what number goes in there. Go ahead and draw arrows real quick. So it's going to be 9 times 5 plus 9 times 2, and that will drop down and become this right here. And since we have a 45 here, we know we're going to be simplifying the 9 times 5, so we might as well go ahead and simplify the 9 times 2. We know 9 times 5 is 45, and 9 times 2 is 18, and therefore we can go ahead and quickly see what goes inside of that box. 45 plus 18 must be equal to 45 plus 18. Now let's read this one together. We have 8 times 4 plus some number being x, we don't know what that number is, it could be any number, is equal to 32 plus 8. Now notice, there's no multiplication sign or any operation there, but we know that anytime you have, we'll go ahead and put it there, anytime you have a number followed by something else, whether it be parentheses or in this case an unknown number, we can imagine there's actually a multiplication sign between. So let's go ahead and draw our distributive arrows, and if you don't see a multiplication sign next to parentheses and there's a number there, you can go ahead and add it if it helps you. So we're going to have 8 times 4 plus 8 times x. So 8 times 4 is going to drop down here, and then the 8 times x is going to drop down here. And again, we can just write 8x. 8 times some number is what that means. So anybody know what 8 times 4 is? 8 times 4 is 32, and then the 8x just drops down to the 8x. And again, we can easily see that 32 plus 8x must be the same as 32 plus 8. What goes in the box? X. So this is, again, just testing you. Can you distribute the number to each on the outside to each number on the inside? And I hope you understand the concept. If you have any questions, just let me know. I'll be happy to answer it for you. Negative 7 times what number plus b is equal to negative 7a minus 7b. And I'm going to go ahead and kind of draw the distributive arrows there. So in this case, this is a different kind of problem because the unknown number is inside the parentheses. Again, we're going to go ahead and draw distributive arrows again. Now notice, for the first distributive arrow, it's just negative 7 times some number. The second one's pretty simple, right? It's negative 7 times b. I did this problem for two reasons. Number one, the unknown number is inside the parentheses, and number two, we have a negative number on the outside. And we'll see more of that in the next lesson, or the next video. So what's negative 7 times b? Well, we can just simplify that in step 3 to negative 7b, or minus 7b, and this is going to stay the same. Now look on the right hand side, it says it's equal to negative 7a minus 7b. So there can only really be one thing that goes in that box, and if you guessed A, you are correct. So negative 7a minus 7b is what happens when we distribute the negative 7 to both of those things inside. Okay. Next, let's go ahead and read this problem together. We have 6 times some number x plus some number y is equal to what plus 6y? Yeah. Let's go ahead and just add that multiplication sign there if it confuses you. So we have 6 times x and plus 6 times y. So the 6 times x drops down here, and the 6 times y drops down here. Now let me go ahead and say something real quick. I thought about this before I recorded. You could write y times 6 right here, right? Because we learned that it doesn't matter what order you multiply two numbers, it's the same thing, right? But in math, we generally like to write the number before the variable. So now we can actually pretty much see, since we have 6x plus 6y, exactly what goes inside this box. So we really don't need to simplify very much. Since it's 6x plus 6y on the left, it must be 6x plus 6y on the right. And it looks like I didn't put the answer there, so we'll go ahead and write it together. So it's going to be 6x. Okay, now this is the general way of writing the rule. A times b plus what is equal to ab plus ac. And this is the general way, or more formal way, of writing the distributive property of multiplication. Let's go ahead and draw our distributive arrows. So it's going to be a times b, which becomes that, plus a times whatever that is, which is how we distribute that. So a times e plus a times what is equal to ab plus ac. Now we know that a times b simplifies to ab, and a times some number just simplifies to a, and then the box, which is the unknown number. And now we can easily see that, no pun intended, ab plus ac is what goes inside the box. So therefore, c is our answer, and that is the general way of writing the distributive property of multiplication. A times b plus c is equal to ab plus ac. And there it is inside the box for you. I wanted to show you real quick that you can actually distribute however many times you want. Okay, you could do it 50 times. So a times b is ab, a times c is ac, a times d is ad, and so on and so forth. You could do it 50, 100, a million times. It doesn't have to just be 2. So in a nutshell, that's the distributive property of multiplication. If you have any questions, I'd be happy to answer it for you.